morning, children. We have studied some parts, no? We have completed like what is electric current, potential difference, resistors, and what is resistance, factors, activities, everything. We will see the heating effect of electric current. Do you agree with me? Some heat will be produced when electric current passes. For example, when you are using a gadget for 2-3 hours, when you are using a tab, when you are using a mobile, you will feel, no, that exothermic we have studied about. Same way here also, when you hold that gadget, you will feel the heat. So heat is produced, right? How is it produced? What is that? We will study in detail. Okay. So heating effect of electric current. We have studied all the other things in detail. So when you are using electric fan, when you are using something, when there is a source of current, automatically it gets heated. It continuously, what happens now, dissipated. What is dissipated? The energy, the heat energy which is produced now in the form of heat. Okay. This is known as heating effect of electric current. See, the source energy continuously means the energy which is coming now when it is passed from or when you are using a source, a battery or a cell or this one, what happens? We will be using it for our electrical gadget. But what happens? Some amount of heat will be dissipated. So the dissipating thing, no, the dissipated energy is in the form of heat. This is known as heating effect of electric current. It is utilized in some devices. We'll see about the usages, that means advantages and as well disadvantages of this heating effect. But this current which is coming, no, this current which is used, when it is used, the heat which is coming out, no, it can be utilized in devices. See, for example, electric heater, electric iron, toaster, to heat things we are using. Otherwise, electricity we are using only to light. No. So, for heating also we are using gadgets where what is used? The heating effect of electric energy is, or electric current is used. We know that I means current, R is resistor, V is potential difference, T is time, Q is charge and all. No. Here W is equal to QV. Okay. W is equal to QV. What is W? The work done. Okay. W is equal to QV. We know I is equal to Q by T. We have studied in the first, the number of, what is Q we have studied, no? What is Q? Charge. So, I, when you are taking I from this, I is equal to Q by T or Q is equal to IT. This is the first equation. W is equal to QV. From that, we are going to find what is Q, what is V. Q is equal to what? I is equal to Q by T we have studied. So, Q is equal to IT. And according to Ohm's law, we have studied that V is equal to IR. That is the second equation. Keeping these two equations in mind, W is equal to Q, we know. Instead of that, you can write, in the place of Q, you can write IT. In the place of V, you can write IR. So, two I's are there. So, we can write I square RT. The formula is W is equal to I square RT. W, what is W? Work done is in the form of heat. So, instead of W, you can also put H. H is equal to I square RT. This is very, very important. H is equal to I square RT. So, Joules law of heating tells that, what is Joules law? H is equal to I square RT. It tells what it is, okay. So, here in this, if you see, H is equal to I square RT, this I have just shown a circuit to see how it is moving. No, current is moving. And potential difference we have studied, the difference in potential difference, then only it will start moving, otherwise there will not be any movement. We have also studied about the potential difference and electric potential. No, to show that I have given this circuit diagram. Now Joules law of heating states that H is equal to I square RT, but what does it define? The heat produced in a resistor, okay, the heat produced in a resistor Three things. It's directly proportional to the square of the current of a given resistance. Here, I square. So it is directly proportional to the square of the current, I square, for a given resistance. What is this? The heat produced in a resistor is directly proportional to the square of the current of for a given resistance. First one. Second one, it is also directly proportional to the resistance of a given current. Okay, it's directly proportional to resistance of for a given current. Third one, it is directly proportional to the time. It is directly proportional to the time for which the current flows through the resistor. So H is equal to I square RT. This is Joules law. Okay, be very careful. This can be asked for 2 marks, or they can ask like Joules law of heating can be expressed in the form of H is equal to I square RT. One numerical we will see based on this. 100 joules of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. Heat they have given 100 joules. Then 4 ohms. Time is 1 second. We should find potential difference. Using this formula, H is equal to I square RT. First we should find I. H is there. R is there. T is there. I is not there. No, I we should find, and then we will find V. I is equal to, how to find I? I is equal to root of H by RT. I square, no, so root I have put. So if you put the values here, you will get 5 amps. What is 5 amps? Current. V, you know, formula V is equal to IR. So in the place of I, if we put 5, V is equal to 5A into 4 ohms. The answer is 20 volt is the potential difference. Okay.